This lesson will cover Big Idea 2, Standard 4, and our topic for today is the flame test. So when we learned about the different models of the atom, we learned that electrons travel in orbitals based on their energy level. And when we are labeling our models of the atom, we use the letter N to represent the energy level. The farther away an electron is from the nucleus, the higher the energy level. So as we move away from the nucleus, the energy level increases. So I'm just going to draw a quick Bohr diagram. This is just going to be for a generic atom. We know we have protons and neutrons located in the nucleus. And then we have our energy levels, and that's where we're going to find our electrons. So we have the nucleus, centrally located, positively charged nucleus. The first energy level closest to the nucleus would be N equals 1. And then we just increase our numbers as we move out. N equals 2 and N equals 3. There is something called the ground state. The ground state is the lowest possible energy level for an electron. The lowest possible energy level for an electron. Think of the ground state kind of like an electron's home base. It's wherever the electron starts. So let's say I have an electron right here in N equals 1. That would be its ground state. That's where it starts out. That's the lowest energy level it can be in. Well, what happens is an electron can absorb energy. And what I mean by absorb is it can gain energy. We can energize an electron by heating it up, for example. If we were to heat up an atom, that electron would absorb some of that heat energy. And when it absorbs energy, it can jump to a higher energy level. An electron can absorb energy and jump to a higher energy level. So let's say this electron absorbs some energy and it jumps from N equals 1 up to N equals 3. We would call N equals 3 the excited state. The excited state is the energy level an electron moves to when it absorbs energy. So the electron starts in its ground state, its home base, or its lowest possible energy level. We can excite that electron through either heat or electricity. It is going to absorb some of that energy. It can jump to a higher energy level, which we call the excited state. Well, electrons don't want to stay at that higher energy state. They want to go back to their home base. So what's going to happen is that electron that's now in the third energy level wants to go back to its ground state. It wants to go back to that home base. So during that fall, from the excited state to the ground state, all of the energy that was previously absorbed gets released in the form of a photon. So the blue arrow is representing what happens when an electron absorbs energy. When it absorbs energy, the electron is going to jump from the ground state to the excited state. The pink arrow is showing what happens as that electron releases energy. When that electron is going to fall from the excited state back to the ground state, it has to release all of that energy. That energy has to go somewhere, and it is going to get released in the form of what we call a photon. A photon is just a packet of light energy. So when that electron releases energy, we are going to see light. A few important things to know. The larger the jump, the more energy either absorbed or released. So we might have a small jump, maybe it just jumps one energy level, or we can have a larger jump, maybe it jumps 3 energy levels. The larger the jump, the more energy absorbed or released. And then just the opposite, the smaller the jump, the less energy absorbed or released. Also important to know the amount of energy released determines the color of light seen. The amount of energy released determines the color of light seen. So here is a picture that I found from Khan Academy that kind of explains this process. So notice that the ground state is going to be energy level 2. Let's say we just had a 1 level jump. We went from a ground state of 2 to an excited state of 3. So that is a smaller energy jump, so we are going to see a lower energy light like red. Let's say we had a bigger jump from a ground state of 2 to an excited state of 4. When that electron falls back to the ground state, we're going to see a little bit of a higher energy light. We might see something like green. If we had a very big jump in energy, let's say we jumped from a ground state of 2 up to an excited state of a level 6. When that electron falls from the excited state to the ground state, it is going to release a lot of energy. So we are going to see a high energy light like violet. It is also very important to remember the light is not seen until the electron falls back down from the excited state back to the ground state. When energy is absorbed, it jumps from the ground state to the excited state. It is absorbing energy because we are heating this element. It absorbs energy on the way up. On the way down, it releases that energy, and as that energy gets released, it gets released in the form of a photon. The color we see depends on how much energy is being released. If a small amount of energy is released, we're going to see a low energy light like red. If a lot of energy is being released, we're going to see a high energy light like violet.